let's solve this problem. Rotate list. Given the head of the linked list, right? Given the head of the linked list, we have to rotate the list to the right by k places. See, we are given this linked list. Okay, we have to rotate this list to the right by k by two places, two times. We have to rotate this list twice. Meaning, see on first rotation, 5 goes to the front, 1 goes to second position, right? And 2 goes to third position, third goes to fourth position, and fourth goes to 5 position on first rotation. And on second rotation, what happens is this 5 goes to second position, 1 goes to third, 2 goes here, 3 goes here, and 4 goes to front. This is what problem is asking. Now, how we are going to solve this problem? How? We have to rotate the list by twice or given k times, right? So how we can solve this problem is, one way is we can use two pointers approach. Okay, two pointers approach. For example, let's say slow. Suppose 1, 2, 3, 4, 5, right? 5. Now we have to rotate this list. This is our list. Suppose let's say this is the head, and this is, let's say, current. We initialize this as the current. Okay. So now let's use two pointers approach, slow and fast pointer approach. Suppose slow is initially at zero position or at the head, okay, at the head, while fast moves ahead by k times. Suppose fast is at this position, okay, fast moves by k times initially. Fast moves by k times. Now we have to move these both pointers ahead, one step ahead, until and unless fast is null. Meaning, while we have fast dot next, right? Until and unless fast dot next is not null, here we have null, right? Is it visible on the screen? Yes. Okay. Until and unless this fastest next is not null, what we do is we move slow dot next and fast goes to fast dot next. Now let's move. Now one step ahead. Fast dot next is not null. So current goes here. Okay. So current is now at this position. And fast moves here. Now it checks again. Is fast dot next null? No. Fast dot next is not null. So again, this current moves here. Right? Current, not current, sorry, slow. Slow moves here. Okay. Slow moves from here to here. And fast reaches here to here. Fast move. Now slow. Now fast dot next is null. Fast dot next is null. Now what happens? What we have to do now is our current. We know our current is this dot head, right? So what we do is we make fast dot next equals to head. See, fast dot next equals to head, and new head equals to slow dot next. This sorry, new head. Here, new head, slow dot next, and slow dot next equals to null. We make slow dot next equals to null. We break this. We break over here. We make this null. And now we return new head. Return new head. Now can you draw the final head here? 4. This is the new head. It's pointing to 5, which is fast, and fast dot next is pointing to previous head. 1 is pointing to 2, 2 is pointing to 3, 3 dot next is null. This is our final head, which this is our final head. Okay, our given head is rotated by twice. Now let's solve this in code. Okay. Suppose let, is it visible on code? Yes. Okay. Make it a little bit upper. Okay, I can remember it. Okay, let current equals to head. Okay, let's make it head. Let length. We have to find the length because we have to basically move the fast by k times, right? By the k times. So I'll show you. So if there is no head, or if there is no head dot if there is no head dot next, then return head or null. Or if k is 0, right? If we don't have to rotate it, just return head, isn't it? So while current is not null, core equals to core dot next, and we find the length of the list like this. Okay, we get the length list like this. Now now we don't have to rotate it like fully. So what we can do is we can remove unnecessary rotations by doing k modulus length. So we don't have to go full n times rotation. Okay, so suppose 2 modulus 5 will be 2, like so. Now for let I equals to 0, I is less than k, I plus. So now we have to basically move the fast pointer, which initialize let slow equals to head or current, right? Let slow equals to head, and let fast equals to head. Initially both are at head, and now we have to move fast by cadence. Fast next. So as I said, fast will move ahead by from this position, right? Fast dot next. Now while fast dot next is not null, or if there is value, right? Slow equals to slow dot next, and fast equals to fast dot next. The loop will continue until the end, or meaning fast dot next. There is a value in fast dot next, and it will end when fast dot next is null at this position. Right? Loop will end, meaning our slow will be at this position and fast will be at this position. Okay, now we have to basically do what you have to do is it's called rewiring. Okay, for example, what we can do is we can rewire or we can point first dot next to where head, head, right? And let new head equals to slow dot next. I will explain this part, which is here we point, we rewire, we point, we what do you say? We point the next pointer of this fast to previous head. We make new head from slow dot next, right? And what we make this null, next pointer null. Slow dot next equals to null, and we finally return new head. I think that's it. See what we have done is this is a corner case. If head is null or head dot next is null or case 0, we return head, right? This part is calculate the length of list. This part is for avoiding unnecessary rotations, and this part is for moving fast pointer, right? Moving fast pointer by k steps, and move both pointers ahead until fast next is null. This is called rewiring part. Rewiring part. Let's check it. Accept it. Let's submit it. Excellent. This is how we solve this problem. Okay, list problem.